Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, we are going through compound angles, and I'm going to be taking you guys through a few examples where I show you how you can use ratios to solve compound angle questions, right? And I'll also be taking you guys through one example where we just do a basic application of your compound angle identities, right? And I'll also be taking you through what special angles are and how we can use special angles to solve compound angle questions. Before we get started with the video tutorial, guys, please make sure that you are subscribed to the channel. Please make sure that you click on that notification bell so that you get notified every time I upload a new video tutorial. Please make sure that you give this video a huge thumbs up because it helps the channel grow and reach more mathematics learners. And also please make sure that you share the channel with your friends. Okay guys, so without any further ado, let's get started with the video tutorial. So what are compound angles? If you have a sum of two angles or a difference of two angles, that's when it's supposed to click to you guys that, oh, hey, I'm actually working with compound angles here, right? And there are actually 4 compound angle identities that you guys are going to be assessed on, right? The first one is sine of A plus B. Second one, sine of A minus B. Third one, cos of A plus B. And the last one is cos of A minus B, right? You need to obviously be familiar with these compound angle identities and just know how to use them. The formula sheet will be provided, or the formulas will be provided for you guys in your test or exams, but it's always good to just memorize or remember these compound angle identities just to help you just go faster or move faster through your paper. Yeah, so a quick way to just remember these compound angle identities is that S means the same. Okay, S is same, right? And C means changes. Okay, so how this is going to help you is that when you have sine of the compound angle sine of A plus B or sine of A minus B, then you can just remember that the sign stays the same, right? So sine of A plus B, your sine, it becomes sine A times cos B plus, right? Cos A sine B, right? So you need to alternate between your sine and your cosine, and the sign stays the same, right? And if you are given cos of A plus B or cos of A minus B, you need to remember that the sign changes, right? And you start with your cosine, so it's cosine A cosine B minus sine A sine B, cosine A times cosine B plus sine A sine B, right? So example 1 is just application of your compound angle formula, and it says that show that sine of A plus B minus sine of A minus B is equal to 2 cos A times sine of B, right? So from what we can see here already, we can see that we have got compound angles, right? So we can apply compound angle identities to help us solve this problem, to help us prove that the left hand side is equal to your right hand side, right? So from here we just need to decide, do we work with the left hand side or do we work with the right hand side, right? From what I can see, I'm thinking we can work with the left hand side because we will be able to use the compound angle identities to expand this equation and hopefully get to the right hand side, right? So let us expand. We know that sine of A plus B is equal to, so sine of A plus B is equal to sine of A cos of B plus, because the sign stays the same, cos of A times sine of B. So that is our compound angle identity, okay? And the other one is sine of A minus B. So sine of A minus B is equal to sine of A times cos of B minus, because the sign stays the same, cos of A times sine of B. Okay, so those are the compound angle identities that we're going to use to help us further simplify this equation, right? So now we're just going to simply substitute these values, right? So where we see sine of A plus B, we're going to substitute that, right? Sine A times cos B plus sine A times sine B. And where we see sine of A minus B, we're just going to substitute sine of A times cos B minus cos of A times sine B. So let's do that. Okay, minus sine of A minus B. So we say that sine of A minus B is equal to sine of A times cos B minus cos of A times sine B. Right? We're going to simply simplify this. So it's sine of A times cos B plus cos A times sine B. We're going to multiply the negative inside. It's negative sine A times cos B plus cos A times sine B. Okay. We are going to add your like terms. So we've got sine A cos B. So we see sine A and cos B. We're going to add those together. So plus sine A times cos B minus sine A times cos B, that is 0. Add your other like terms, plus cos A times sine B plus cos A times sine B. So we've got two of those, right? Cos A sine B plus cos A sine B. That means that you've got 2 cos A times sine B, right? And what do we see? We see that we've basically proven that your left-hand side is equal to your right-hand side, right? So that which is equal to your right-hand side. Okay, so here we're just supposed to say that we're starting with your left-hand side and then show the proof like that. Okay, so first thing we're supposed to see here is that obviously you're working with your compound angle identities. Simply expand sine of A plus B as well as sine of A minus B. And from there, we added your like terms to prove that your left-hand side is equal to your right-hand side. Okay, let's go on to the next question. Example 2. So this is application of your compound angle formulas or compound angle identities as well as using ratios, right? Let's just have a look at the question. The question is saying, determine the value of sine of A minus B if 5 cos A minus 4 is equal to 0 and 12 tan B plus 5 is equal to 0. We are told that the angle A and B are in the first two quadrants, right? So with this question, the first thing we need to do is we need to write out this trig identity of sine of A minus B, okay? And we said that sine of A minus B is equal to sine A times cos B minus, because the sign stays the same, cos A times sine of B. Okay. From here, we see that we basically need to define our trig ratios in terms of sine A cos B as well as cos A sine B, right? So if we're given this additional information that 5 cos A minus 4 is equal to 0, and 12 tan B plus 5 is equal to 0, that will help us to define our angles or our trig ratios in terms of angle A as well as angle B, right? So that is exactly what I'm going to do. So I'm going to write the 5 cos A minus B as well as the 12 tan B plus 5, which is equal to 0, onto the next page. All right. From here, what we need to do is we need to isolate your cos of A on your left-hand side, right? And we also need to isolate your tan of B on your right-hand side, right? So let's just do that. Okay. So what I basically did here, I moved your negative 4 to your right-hand side. It becomes a positive, and I divided by the 5 so that it cancels on the left-hand side. So your cos of A is equal to 4 over 5. Let's go on to your right-hand side. Okay. Same thing here. Tan of B is equal to negative 5 over 12, right? What did I do here? I moved your positive 5 to the right-hand side, and it becomes a negative 5. and I just divided by the 12 so that it cancels on the left hand side, and we have 10 of b, which is equal to negative 5 over 12, right? What other additional information was given to us, right? We are told that a and b, so the angle a and b are on the first two quadrants, right? Why am I saying that they're in the first two quadrants, right? Because we are told that it's from 0 degrees to 180. So that tells us that we're working in the first two quadrants for both angle A as well as angle B, right? Remember, I told you guys about all students take care to help you remember where your trig ratios are positive, right? So all students take care. All students take care. All right. And then from here, we've got cos of A is equal to 4 over 5, right? So we need to work in the quadrant where cos is positive because we've got positive 4 over 5, right? Let's have a look at tan of B, which is equal to negative 5 over 12. We need to work in the quadrant where your tan is negative, right? Because we've got negative 5 over 12, right? Okay, because we are told that angle A and B are in the first two quadrants, right? When we look at a quadrant where cos is positive, we need to take into consideration that we need to be working in the first two quadrants. When you look at the quadrant where tan is negative, we need to take into consideration that you need to only be working in the first two quadrants, right? So let's start with the left hand side. Cos of A is equal to 4 over 5, right? Like we said, we mentioned that we need to work in the first two quadrants because 0, 90 degrees, 180 degrees, right? Okay, first two quadrants because we're working from 0 degrees to 180 degrees, right? Okay, and then where is cos positive in these first two quadrants? Cos is positive in the first quadrant because all of the trig ratios are positive in the first quadrant. Therefore, that is where we are going to draw our triangle. Let's have a look at your right hand side. Here we've got tan of B, which is equal to negative 5 over 12, right? We're working in the first two quadrants because we are told that we're working from 0 to 180 degrees, okay? So we're working in the first two quadrants, right? And where is tan negative in the first two quadrants? Tan is negative in the second quadrant because only the sine ratio is positive in this quadrant. So tan is negative there, right? So we've basically used an aid of a diagram to help us in defining our trig ratios, right? So let's just fill in our angles, okay? Here, that is our angle. That is our angle A, right? And here, that is your angle B, okay? From here, we can just simply define our trig ratios using the sketch that we've drawn, right? We know that cos of A is equal to your adjacent over your hypotenuse, right? Because so, ka, toa, right? Or we said that we can use shave your rear, cos x-ray, tan your exterior, right? So cos of an angle is equal to x over r, right? So this 4 is your x and this 5 is your r. So we're going to put that into our diagram or on our diagram. So the 4 is our x, right? So that goes onto our x-axis, and your r is your 5, right? So how do we calculate the y? We simply use the theorem of Pythagoras to get your y. So it's going to be r squared is equal to x squared plus y squared. We're simply solving for y. We want to get your y, right? So we can simply substitute the values that we have, right? So your x is equal to, your r is equal to 5 squared, which is equal to, your x is equal to 4 squared plus y squared. Solve for y, or you isolate your y, you're going to have 5 squared minus 4 squared is equal to y. Okay, so that is your y. If you put that onto your calculator, 5 squared minus 4 squared is equal to 3. Okay, so the y there is equal to 3. Okay, let's go on to your right hand side, right? Tan of b is equal to negative 5 over 12, right? We said that you can use SOHCAHTOA or shave your rear, cos x-ray, tan your exterior, right? So for tan, it's y over r, right? So that is your y and that is your, For your tan, it's y over x, right? So that is your y, right? And that is your x. However, we're not sure where that negative applies. Does it apply to the y or does it apply to the x? So to determine how or which value does the negative apply for or apply to, we need to go onto our diagram, right? So on our diagram, we already know that, right? Your y is equal to 5. Okay, we already know that the y is equal to 5. And we already know that the x is equal to 12, right? Right? So what do you see? Because you're in the second quadrant, right? In the second quadrant, your x values are negative, right? Therefore, the negative applies to your x. Okay? From here, we can just use the theorem of Pythagoras to help us calculate the value of our r. So r squared is equal to x squared plus y squared, right? In other words, r is equal to the square root of x squared plus y squared. Substitute your x, so your x is equal to negative 12 all squared plus your y is equal to your 5 all squared. Punch that into your calculator to find that your r is equal to, okay, so your r is equal to 13. Okay, we're simply going to put that onto our drawing, right? From here, we will be able to define our trig ratios in terms of our angle A as well as our angle B, right? So from here, we can just go back to our question and substitute sine of A. What is sine of A, right? Okay, so we go to our angle A. What is sine of A? Sine of A is your y over your r. So what is your y is 3, what is your r is 5. So sine of A is 3 over 5 times what is cos of B. You go to your diagram that has your angle B, right? So what is cos? Cos is x over r, right? So what is your x? It's negative 12. And what is your r is 13, right? So it's negative 12 over 13 minus cos of A, right? You go to your diagram. Okay, the diagram that has your angle A. So what is your cos of A? Cos of A is x over r. So what is your x? It's 4. What is your r is 5. Multiply by sine of B. You go to your diagram that has your angle B. Okay, so sine of B is y over r. So what is your y? It's 5. And what is your r is 13. Okay, you simply simplify this. 3 over 5 multiplied by negative 12 over 13. That is equal to negative 36 over 65 minus, right, 4 over 5 times 5 over 13. Just put that into your calculator. You'll get 4 over 13. Your final answer is negative 56 over 65. Okay, and we are done. Okay. What's important for you guys to note here is that the first thing you're supposed to do is obviously write out this compound angle identity, right? From writing out your compound angle identity, that's when you are able to see that you need to define your trig ratios in terms of angle A and B, right? Then we look at the additional information that was given to us. Cos 5 cos A minus 4 as well as 12 tan B plus 5, right? What we did here is that we basically isolated the cos of A and we isolated the tan of B to get 4 over 5 for cos of A and to get negative 5 over 12 for tan of B. From there, we looked at the other information that was given to us. We are told that angle A and B are both in the first two quadrants. Why am I saying they're in the first two quadrants? Because we are told that it's from 0 degrees to 180 degrees, right? So from here, right, we look at after isolating your cos of A. What is this value? Is this value positive or is it negative? If it's positive, that tells you where you should be focusing on, right? So because we're working in the first two quadrants, where is cos positive in the first two quadrants? We found that it's positive in your first quadrant. That's where we drew our diagram. And then when you looked at tan of B, which is equal to negative 5 over 12, where is tan negative in the first two quadrants? Tan is negative in the second quadrant because only sine is positive in this quadrant. So tan is negative, and that's where we draw our diagram, right? From here, it becomes easy. All we need to do is find the missing side, and on the left hand side it was y, and on the right hand side it was your r, right? Okay,
And then from there, we will be able to define our trig ratios in terms of A and B, because we will have your X, the Y, as well as the R. Same here, we've got the X, the Y, and the R. And then you simply go back to your sine A times cos B minus cos A times sine B. And you substitute this, taking into consideration the angle that you're working with, right? So here you've got A, you look at your diagram that has your angle A, right? And then here you've got B, you look at your diagram that has your angle B. And that's what we did. Okay, guys, and we are done.
Right, guys, so on the next video tutorial, I'm going to be showing you guys how we can use spatial angles to solve this example, right? So like you can see here, it says that use the formula for cos of x minus y to show without using a calculator that cos of 15 is equal to square root of 3 plus 1 over square root of 2, right? So if you don't have knowledge on spatial angles, it'll be hard for you to solve this problem or even to prove that cos of 15 is equal to that, right? But if you have knowledge of spatial angles, you'll be able to know that cos of 15 can be written as cos of 60 minus 45, right? And then from here, we can use your compound angle identity for cos of an angle minus an angle to expand that, right? So that we get to that solution, right? So in the next video tutorial, I'll be taking you guys to spatial angles, what are spatial angles, right? And how we can use spatial angles to answer your compound angle equations, right? Please make sure that you are subscribed to the channel. Please make sure that you click on the notification bell so that you get notified every time I upload a new video. And guys, also please make sure that you give this video a huge thumbs up because it helps the channel grow and reach more learners. And I'll see you guys on the next video tutorial. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.